So today we are going to see what is accuracy in image classifications. So suppose we have a deep learning model which can classify our image and tell us whether it is a cat or a dog or let's say 100 other classes. And then let us say that we have these 4 samples, sample 1, sample 2, 3 and 4. The first sample is actually an image of a cat. The second sample is actually an image of a dinosaur. The third one is of a rat. And the fourth one is of a rabbit. When we send these samples to our deep learning model, it gives us a prediction. But in the prediction, it says the cat image is a cat image. The dinosaur, it predicts as a dog, let's say. And the rat, it predicts correctly as a rat. And the rabbit, it predicts as a cat. So let us find out what is the accuracy of this deep learning model based on these predictions. So accuracy is correct predictions over total predictions. So in our case, the correct predictions are cat, then this is not a correct prediction, this is a correct prediction, and this again is not a correct prediction. So in our case, the correct predictions are
cat to cat and rat to rat. The other two predictions, they are not correct. So correct predictions are 2 divided by total predictions, that is 4. That gives us 0.5 or 50% accuracy. So this is a case of a multi-class classification. Let's see what happens in a binary classification.
in a binary classification, the labels are either cat or non-cat, that is only 2 classes are there. And the model can also predict it either cat or not cat. So let's say in this case it predicts cat, in this one it predicts not cat, and this predicts cat. So what will be the accuracy of this deep learning model? So we'll use the same formula. Accuracy is equal to correct prediction divided by total predictions. So in our case, the correct predictions are cat, not cat, and this one is a wrong prediction. So our accuracy will be 3 divided by total predictions, that is 4. So it will be 0.75 or 75% accuracy.
Sometimes the alternate formula, that is true positive plus true negative divided by total predictions, is used. So let us see if this matches our formula. So the true positive cases are the ones where the prediction is true and the classes are positive, that is cat. And in true negative, the predictions are true and the classes are negative, that is not cat. So cat to cat is a true positive class and not cat to not cat is true negative class. So if we see how many true positive cases, so that is 1, and how many true negative cases, that is 2. So according to the formula, 1 plus 2 divided by 4, so that gives us 0.75, and that is similar to what we achieved using our previous formula. So these two formulas are used interchangeably depending on the circumstances and what we are trying to find out.